Okay, so this is a new chapter for us. That is the entity relationship modeling, ERM. Okay, so my base reference is from the book Database System Design, Implementation and Management, 9th edition. Alright, this topic will be familiar with you because we already used somehow in our previous lecture. Okay, but we'll focus in this part how the entity relationship modeling is made. Okay, importantly for you to know the jargon, the syntax, the terminology, and what makes this presentation is named as an ER modeling. Okay. So the objective of this topic, okay, you will learn about the main characteristic of ER components, the relationship between entities, okay, and how this ER modeling is designed and developed. Okay, that is very much important, how to actually draw the ER model from the case study, from the given situation for addressing the database problem. Yeah. So when we talk about the modeling, in any case, usually we model the solution. That is, we design the solution before we implement it. Implement means we practice it. Okay, so system design. Okay, we design the system first before we implement it, before we program it. Okay, so same goes to the database. We design it first before we go for the implementation. Okay, the ER entity relationship is stand for the ER model. It is a high-level data model, and this model is used to define the data elements and its relationship for a specified system. Specified system means that for the case you are dealing with. Okay, it develops actually the ERM is actually a conceptual design for the database. Okay, it make it easy. The design make us easy to understand and to view the data. Okay, and the ERD, okay, ER diagram is a diagram that represent the database structure in ER modeling. Okay, so it is a diagram that presents the database structure of ER. Okay, so this is the example of the ER diagram. ER diagram. Okay, so this is the example of ER diagram. Okay, diagram, and it is produced under the ER modeling. Means we draw, okay, this diagram based on the syntax, or based on the structure, based on the format provided by the ER modeling. Okay, maksudnya kita akan guna semua simbol-simbol, semua terminologi yang telah disetkan di bawah standard ER modeling. Tak bolehlah guna yang di luar daripada, selain daripada itu. So this is the ER diagram. So ER modeling is based on the two concepts. Okay, the first part is the entities, the second is a relationship. Okay, entities and relationship. Okay, so from this example, which is the entity? So the student is the entity. Okay, this is the entity. Okay, and the other one is a course. The course is also the entity. Okay, it defines. So what is the entity? Again, entity is any object. Remember, any object usually with attributes, with the characteristic. So in the database, the entities is defined as a table. Okay, remember the table. Table of student. Table of student. Okay, a table of course. Okay, and the column defines the attributes. This is the attributes. Okay, so from the example, the attributes like SSN, the number, the name, yeah, the email, and so on, if any. Okay, again, entities defined as tables that hold specific information. Okay, and the next part, okay, that connects two entities named as a relationship. So relationship is an association or interaction between entities. So having this definition and also the concept, entities and relationship, it makes that the ER diagram cannot be stand alone with only a single entity. For example, student entity like this. So it cannot stand alone. Okay, this is not a complete ER diagram because it doesn't have a relationship. At least they have a self relationship, at least self-own relationship. So that makes the ER diagram, entity relationship. Right. Go to the next important items under the ER. Okay, it forms the basis of ER diagram, and it represents conceptual database. Yes, and they have the three components. Okay, three components. Previously, we looked into two, that is the entity and relation, but actually between it, in the entity, of course, we have an attribute of entity and attribute. We cannot have like this situation. For example, entity, okay, relation with entity, okay, without attribute. Usually cannot. Okay, without attribute. Okay, we need to find out the attribute of the entity. So it makes the definition of the entity, because entity is an object. Any object usually have attributes. Have an attribute. At least the name. Kan? At least the name. Ada tak objek yang tak bernama? Tak ada kan? Okay, so entity and attribute is a must in this situation. Okay, ER model component, we have entity, the attributes, okay, and the relation. Sorry, this should be in rectangle. Okay, and then this is their features. Entity, we have strong entity, weak entity. Attribute, we have key attribute, composite attribute, multi-valued, derived, and so on. This is the character of the attribute. And relation, we have one-to-one, one-to-many, many-to-one, and also many-to-many. Okay, so this is a simple description of the ER model component and its character. Okay, we go to the first item, that is an entity. It is an object in the real world. Yeah, it is an object with an independent existence that can be differentiated from other objects. Okay, so an entity might be, for example, an object with physical existence, student, car, lecturer, classroom, okay, laboratory, building, and so on. Okay, or an object with a conceptual existence. Concept, maksudnya benda tu tak ada. It's not in physical existence. For example, the course, your course now, it is not in a physical existence. It is a concept. A job, a position, a grade, for example. Okay, so this is with the entity. Okay. Entity correspond to the table. Yes, in the relational environment, we have two symbol. Okay, two format. Okay, that formatize the presentation of the ER. First is a chain model. Okay, and second is a Crowfoot model. So this is a two chain model represent the ER by using a rectangle for entity and a node, okay, or oval for its attribute. Okay, but the Crowdfoods uses this table rectangle all in one. It contains the entity's name and also its attribute. So this presentation is more like to the class diagram. Okay, class diagram. Okay, both can be used unless in the question they require or they state specific which model, then you need to follow. If it is not stated any model, then you can use any. Okay, entity name, a noun, usually written in a capital letters. It's a noun. Okay. Okay, entities can be classified based on their strength. Entity ni ada dia punya kekuatan dia. And entity is considered weak if its table are existent dependent. Weak if they are dependent. That is, it cannot exist without a relationship without another entity. Ada entity yang beginilah. So its primary key is derived from the primary key of the parent entity. Okay. The common example is dependent for the employee, for example, or spouse of the employee. In the database employees, okay, in the table employees, they usually exist this kind of situation that they all employee have dependent waris macam itulah hubungan kan, or the spouse. Okay, so the entities of spouse or dependent, this one, okay, is denoted as a weak entity because it depend on the table employee. It depend on the entity employees. Okay? Like this. Or else student. Okay, or student. You have the dependent, not dependent, what? Waris kan? Waris. So the entity waris. There is the data of the waris for the student. Okay, but it cannot be used unless the student's data is there. It cannot be exist without the student data. So it makes the waris table is a weak entity. Yeah. An entity is considered strong if it can exist apart from all of its related entities. Biasa yang objek yang agak ni memang semuanya strong entity lah. Student, course, lecturers, car, building, apa lagi, banyak lah. Kebanyakannya adalah strong entity. Cuma bila dia terbitan, dia dah jadi weak entity lah. When it is depend on the other entities, then it can be recognized as a weak entity. The other category of the entities is a associative entity. Associative entities. So this entity usually derive from the relation. Remember, many to many relation. So we want to reduce many to many to one to many. Then we upgrade the relationship to be an associative entity. So there come the associative entity. We will learn this later on. Okay, so that is an entity. Now the things that can attach with the entity is an attribute. Okay, an attribute. So attribute define the characteristic of the entities. Characteristic features of the entities. Okay, so this is a notation. If you are using the chain, the attributes represented by oval shape. Okay, connected to entity rectangle with a line. Okay, so each oval contains the name of attribute it represents. For example, an employee, okay, they have the attributes name, address, birth date, salary. So if it is in table form, then it is written like this: table employee with the attributes name, okay, address, and so on. So remember, what is this? This is relation. Relation. Okay, table relation. And if that is a schema, we also can represent it in the database schema. Employee. Okay, name. Name, data type. Okay, then address. And so on. Okay, it is usually in a single line. That is a schema. Another schema you can also write like this: employee. Okay, this is name, address, and so on. Okay, so this is a schema. Okay, and then this is the chain notation and Crowfoot notation. Attributes written in attributes box below entity. Rectangle. Ni macam mana tadi? Yang Crowfoot. So it is a single rectangle. Okay, employee. Then we wrote down all the attributes: name, address, and so on. Okay, so this is a Crowfoot. Crowfoot, this is chain. Okay, only these two is an ER. Don't confuse, okay? So these two ER. T. Okay, and this is a schema. This is a relation. Okay, don't confuse yourself. So during the examination, maybe you need to remember the keyword, whether it is to write the ER, whether it is to write the schema, or to write the relation. Okay. Alright, attributes. Okay. For the attributes, for the entity, we must have an attribute. We must have a value. Okay, so this is a required attribute. Optional attribute may be left empty. Okay, so this is the features of the attributes. Okay, usually for one entity, we must have at least one or two attributes. Okay, and the attributes have their own character. Some attributes must have a value. For example, metric number or student number, ID. So it must have the value. Or somehow we have attributes that can be left empty, can be null. For example, apa yang boleh null? Okay. If it, for example, for student, the null value may be address can be null. Somehow address can be null for some moment. Okay, but you need to update it. Or the hobby or the what. So this is the optional attribute. Okay, the domain set of possible values for an attribute. So this domain present us the set of possible values for one attribute. For example, name. So is there any possible values for name? No. Okay, so we go to another example. Age. We have a set of possible value for age? No. How about the address? For the address, maybe we can have more than one address. Home address, current address, okay, postal address. So there is a domain for the attributes. Then we have identifiers. Okay, either which of the attributes is a identifier. So we can recognize it by using their syntax. Okay, one or more attributes that uniquely identify each entity instance. Next is a composite identifier, primary key composed of more than one attribute. So these two is known as an identifier, but one is the single identifier, then the second one is composite. Okay, identifier, for example, ID. Okay, this is a identifier. In this case, this is a just identifiers, primary key. But if we have two, for example, here ID2, Okay, then we combine it together, then this will be the composite identifier. Okay. Other features of the attributes is composite attribute, that it can be subdivided. Ini apa contoh? Subdivided. What's the example? The phone number, telephone number, because we have a country code, and also the number itself, phone number itself. Okay, so this is what we mean that attributes can be subdivided. Okay, but usually we have a simple attribute cannot be divided. Okay, so this is can you get me the composite attribute? That is, the attribute can be subdivided. So my example is phone number. We have a country code and also the phone number itself. Others like maybe postal code. Okay, postal code. It can be divided. Okay. So that is a composite and simple attribute. Next, we have single attribute and multi-valued attributes. What's the example of this? Is name. Name is a single value lah. Okay. What else? Year, tahun. So also a single value. How about the color? Your dress color now. Is it single or multi-valued? Usually multi-valued lah. Okay, your dress code color, your car color, your phone color, for example. Okay, so this can be can have multi-value. Maksudnya kita tak boleh nak beri solid one. We cannot assign one solid answer for the color. For example, yeah. Shape. Mungkin pada salah satu situasi. Sebab contoh kalau shape apa shape rumah contohnya kan. Dan rumah contohnya tu terdiri daripada banyak bentuk kan. Boleh juga kita consider dia sebagai multi-value. Di antara contohlah multi-value ni. Composite attribute tu, ni contoh tadi, phone number. Phone number kan ada yang dengan country code dia. Kan? So we can actually, they have two, can be divided lah. So this one brings the definition of country code, and the rest is the phone number. Kalau dulu ini pun boleh jadi ni kan. Satu sama lagi IC number. IC number. Malaysian IC number. So we have in between the code 00 or 01 or berapa lagi 02, 114 and so on. So it defines something. So we can consider that IC number also can be composite attribute, which is the value can be subdivided. Okay. Apa lagi yang ada kod-kod ni biasanya boleh membentuk ni lah composite attribute. Okay. Means that another example, if we give the value, then we can create we can get another information. For example, if I'm giving you the metric number, your student metric number, I can get another data. For example, your metric number is AI 2000 0012. For example, like this. So I can we can get more data from this. Like this is a program code. And this one is the batch number. Okay, the which year you are enrolled in, the first year, and the rest is the student number. Student number. Student number. Okay, so this is a composite attribute. Clear? Okay. Next, ni tadi contoh tadi lah multi-value attributes. This is the example. So I skip this part. Okay, attributes. Many-to-many relationship and multi-valued attribute should not be implemented. Okay, should not be implemented. Maksudnya, if we have this situation, we need to do something. So this fall under the normalization later on. Okay, and then if you found the many-to-many relationship and also the multi-valued attribute, so what the solution? The solution is to create several new attributes for each of the original multivalued and to create new entity composed of original multivalued attributes. Okay, multivalued attributes. So this is the solution. Solution if you found any of these two situations. If you get the many-to-many relationship, one, and second is multi-valued. So this is the things or what you can do to solve this situation. Okay. Okay. This will be explained later. Okay, this one is macam yang tadi lah. Okay, we just, for example, student metric number. Metric number. So this is the student. Student. This is the ID, and then it contains like this. Okay, then the solution is we just create a new attributes. Somehow we just remove this one and connects with the original entities. Okay, and for this one, many-to-many relationship. Many-to-many relationship. Okay, remember, student, enroll, class. Okay, enroll class. So it makes student, enroll the class. So this makes many-to-many relationship. Okay, because one student enroll one class, but when we generalize it, many students enroll many class. Okay, so we have many-to-many relationship. So how to do this? We upgrade the relation type to become a composite entity. Okay, composite entity. Yes, so it become like this. Student, okay, enroll class, enroll class, okay, and it can be split up. Okay, so we will study this one on under the normalization later. Alright. Next is a derived attribute. Value may be calculated from other attributes, but it need not be physically stored within a database. So this is a derived attribute. So what's the example of this? Derived attribute may be calculated from other attributes, but it doesn't need to be stored in the database. The simple example is a annual salary. Remember, for the employee. Okay, the data salary is enough to be stored in the database. No need to store the annual salary because it can be calculated directly from the so-called dependent attribute. Okay, annual salary. Okay. Right. So this is the example, this description of a derived attribute. Okay. Next, derived attribute. Another example, for example, if they keep the data date of birth, then of course they know the age. Instead of keeping the age information, it is better to keep the date of birth data, because from date of birth we can calculate the age, but from the age we cannot calculate the can calculate the date of birth. Maksudnya age dia akan jadi data yang static, but date of birth, the age can be calculated even the year is moving. Okay. Next. Okay, so that is the entities and also attributes. Okay. Now we go to the relationship. Okay, it is an association between the entities. Okay, participants are entities that participate in a relationship. Okay, we have usually operates the way we read is in both direction, and this is a 4 classification of relationship: one to many, one to one, many to one, and also many to many. Okay, and this part must be avoided. And the solution is we do the normalization. Okay. Relationship. This is it's the 4 classification of relationship. One employee manage one department. Okay. One publisher supplies many books. Okay. One section has many books, or many books has in one section. One course enrolled by many course enrolled by many students. In database, somehow we think that one student enroll one course, but when we see in the large perception, one student enroll one course, one student enroll many courses. This is happening. This is real. Okay, one student enroll many courses, and then one course is enrolled by many students. So it makes many students enroll many courses. Okay, next I go to the connectivity and also cardinality. It defines the relationship classification, connectivity. Okay, one to one, one to many. Okay, and the cardinality express minimum and maximum number of occurrences. Sebelum ni, before this we just learn that the things is one or many, kan? Many. But cardinality, okay, defines specifically the number, minimum and also maximum. Somehow we can define it, somehow we cannot. For example, in the class, yes, we can define it. One section can have a maximum 35 students, for example. So the definition is 135. 135. So this is for the case if you have the value of minimum and maximum. If not, just left it as left the cardinality as one and many. Many is described by M. Okay, so the information written here is established by the business rule. Again, business rule. Okay, if you can get the clear and very concise business rules, then you can get this definition. If not, so you cannot give this. Okay, for example, business rule. One professor, okay, teaches many class. So if you are talking with the your stakeholder like this, and he returns information or statement like this, here in this faculty, one professor teach many class. That's it. So you can just define it one and many, okay, without the concise value. But if you are seeing for example, the registrar, he said that in FSKTM, okay, they define that one professor must teach at least 1 to 2 class only. So you have the concise statements of the business rules. So you can define the cardinality. This cardinality. Okay. So this is the description of the relationship. Okay. Relationship. Remember, this is a relationship. And in the relationship, you can define the connectivity and also the cardinality. Connectivity is the classification, and cardinality is the precise minimum maximum value of the occurrence, entity occurrence. Okay. Any question? Okay. So next, existent dependence. This one is entity exists in database only when it is associated with another related entity. And then entity can exist apart from one or more related entities. Ini dia punya existence lah, dependence. For each entities, whether they have the dependence or not. Somehow it can stand alone. Somehow the occurrence is depend to other entities. So this is go back to the example of employee with its spouse, or student with its parents, not purpose of parent, waris tadi lah. Okay. Relationship strength, weak and also strong. Previously we have the strong and weak entity. Here the same. The relationship also we have the weak and strong entity. And it is denoted by yang weak ni silap. Okay. Alright. Yang weak usually denoted by this line, and the strong is denoted by the solid line. Okay. Like this. The cost generates class. Kenapa dia weak? Because class is created when the cost is there. So it makes the relationship here is weak. Okay, is weak. Class cannot occur without the cost. But the cost is there. The cost is there. Can you imagine? The cost is predefined. The cost is set up with the program, but it's not class. Class can be happening or not. Class tu dicipta ataupun tidak pada setiap semester. Sometimes you know that in every semester not all cost is offered. Okay, is offered. So whenever the class the cost is not offered, then the class is not created. Okay, so it makes the class entity is weak. It depends on the cost entity. Tak faham? Cost BIT20803. This is cost. Okay, BIT20903. This is cost. You know, subject. Okay. Kenapa class jadi weak? Kerana class ni section. Can you imagine? Section 1, section 2, section 3 sampai berapa-berapa. Okay. But this cannot not exist if the cost is not offered. That it makes classes depend with the cost. Faham tak? Ya, sebab kelas tak boleh berdiri sendiri. Kelas tu tak boleh sentiasa, kelas ni tak sentiasa ada. Untuk kes fakulti lah contohnya kan. Kelas ni tidak sentiasa ada setiap semester. Kan, bila kos ditawarkan barulah kelas wujud. Kalau tidak, kelas tak ada. Jadi dia menjadikan kelas ni bergantung kepada kursus ni, kos ni. Sebab tu dia jadi hubungan tu lemah. Dia bukannya entity yang lemah. It's not the class entity is weak, but the relationship yang weak. Relationship yang weak. Sebab tu ni tengok gambar ni. Okay, weak. Okay, harap boleh faham lah situasi yang ni. section. Okay. Yang ini, okay, a strong identifying relationship, course and class. Yang ini, you nampak ini weak, ini strong pula. Kan? Strong. Strong sebab pada waktu ini, kedua-dua course dengan class ni ditawarkan. Is offered. And is created. So, they have. For example, in semester 1, the code for BIT20803 is not offered. But in semester 2 is offered. So, dalam keadaan yang lain, dia akan jadi strong, dia kadang jadi weak. Okay? Jadi weak. The situation. So, it comes back to the business rule, the definition. It means that different organization will have a different rules. Yeah, the business rule. So, the database that they kept is also somehow different. Yeah. Okay, weak entity means two conditions: the existent dependent and primary key partially or totally derived from the parent. This is yang ini adalah weak entities pula. Ini weak entity, ini yang tadi sebenarnya dah explain dekat sini. Weak entities. Okay, dependent and also the employee. Okay, dia punya drawing like this. Okay, double line of the rectangle that shows this is a weak entity. So depend on the employee. Okay, it doesn't have any specific role in the whole picture of employee, but somehow we need the data so that it makes this is weak, and without the employee the dependent cannot occur. Okay, so it makes another reason to note that this entity is weak. Again, database designer determines whether an entity is weak based on business rule. So, kita tak boleh nak buat dia fix lah. Bergantung kepada business rule. Di mana operasi itu berlaku. Example. So this one is a relationship participation. We have optional and also mandatory. This is the previous relationship participation. We have 4 class. Okay. The class is optional. Example, figure 413. Class is optional to the course. So it makes that one course generates 0 to many class. Maksudnya apa ni? It means that at one time the class cannot be exist. Bukan cannot be, maybe not exist. Tak ditawarkan kan? Contohnya di semester 2 kelas ni tak ditawarkan. So it can have the 0. So class is optional to the course. Not every semester we have this class for that course. On the other situation, course and class in a mandatory relationship. So when it's mandatory, so it makes the minimum must be 1. Minimum cardinality will be 1. You can see, do not confuse because the situation may happen. Okay, sometimes the same situation, but they change the types, the classification. But it goes back to the business rule. Okay, because for example, in a FSKTM study, okay, we have several courses, and the courses is not offered for each semester. So we have the information of semester. So that's why this situation is coming in. Some semester we offer class, so the class is mandatory. But the other semester, the same class is not offered, so the class will be optional. Okay? Will be optional. Okay. Right. So let us recap. This is what have been explained in the past about 40-50 minutes. Okay. We have the entity symbol. We have the attribute symbol. Okay. This is what defined under ER modeling, entity relationship modeling. Okay. Then we have a relationship, the degrees, the cardinality, okay, and also the relationship. Okay. Yang degrees unary, binary ni belum lagi. Okay. So it's not yet explained. Unary and binary. But somehow I already explained the binary, the unary. Unary is to have a relationship with with the same entity. Entity have a relationship with himself lah. Okay. That is a unary. The rest is a binary. Binary. And then also we can have ternary and quaternary. Okay. This is a symbol. You need to use the correct one when you are required to draw the ER. Okay, so this is for the chance. Chance model. Chance model. Crowdfoot is easier. All is denoted in rectangle. Okay. Right, I continue with the relationship degree. So it indicates, the degree indicates number of entities or participants that is associated with a relationship. The first one, we have a unary. The common one, we have a binary. And rarely happen, we have a ternary relationship. 1, 2, 3. Okay, association is maintained within a single entity, that is a unary. But mostly we have the binary relationship. This is the presentation, the form of relationship degree. This is a unary relationship. Employee, manage, employee. Okay. Binary relationship, professor, teachers, class. Okay. And ternary relationship. Conceptually, we see that doctor prescribe the patient. Also, doctor prescribe the drug, the medicine. Okay. But in implementation, logical, it is upgraded into this one. Okay. So this makes the difference between how conceptual relationship can be can be upgraded into this one. Must be transformed whenever we implement in the real database. We cannot directly transfer or transform this information to the physical database. So we need to make like this. So we upgrade the relationship prescribed, okay, to become a prescription entity. Okay, so the entity can be related to the doctor. So looking into this solution, you can see that finally, the ternary relationship is converted into the binary relationship. Binary relationship. We cannot just simply implement the ternary relationship in the real database. So that's why we have come with the solution. Solution to implement in real database. Okay, so this is the implementation description. Okay. Recursive relationship. A relationship can exist between occurrences of the same entity naturally found within the unary relationship. Okay, ni yang tadilah. It is connected with himself, with the same entity. Okay, so this is the example. Okay. associative composite entities, also known as a bridge entity. Associative entities has something to do to implement the many-to-many relationship. So it composed of primary keys of each of the entities to be connected. Okay, and it may also contain additional attributes that play no role in a connective process. So this is a associative entities. Example is like the previously I explained, one class, okay, one student and class or course. So it makes many student enroll many class. So there comes the associative entities whenever we normalize this situation, because we do not want many to many. We do not want. Okay. Then we upgrade the enroll to become a associative entity. Course and student. Similar with the situation, doctor prescribed the drug, doctor prescribed the patient just now. Okay. So when we upgrade the relationship to become an entity, so this created entity is named as a associative or composite entities. Kalau yang ini, in this case, the primary key is obtained from the parents. So the primary key for this one should be student ID and also the course ID. Course ID. Will have two primary key. Okay, primary key. Course ID. Student ID. Associative entities. Okay. This is the conversion. We will go deeper in the normalization later. This is the concept how we should convert many-to-many relationship into the one-to-many relationship. Example. This is the illustration how the composite entities is created. Look at this. Student enroll class, and then the enrolls is converted into the composite entity. Look at this, the primary key, the class code, and also the student number in this case. So the number coming from here and the class code coming from here. And they may also have their own attribute. Okay, so developing an ER diagram. So database design is an iterative process. Yes. It creates detailed narrative of organization, description of operation. It is not easy to obtain the 100% concise information, concise business rule from the company. So it makes the process is iterative. It can be changed. Okay. Identify business rule based on description of operation. Okay. Identify main entities and relationship from business rule. Develop initial ERD, identify attributes and primary key, then revise and review the ERD. So this is the activity in your project. Should be happening in the next week. Maksudnya you may start to do the data collection. You can start to do the interview. Okay, so the one of the role or the function of the interview or the aim is to get the business rule for the company from the company. From the business rule, you can then identify the entities and its relationship. After that, you can draw the ERD. Okay, after drawing, then also you can identify the attributes and primary keys that is relevant to their company. Okay, so this is your project activity. I hope all of you can submit the proposal for checking, and at the same time you can go for the data collection. Okay, data collection is this lah. In this case is a database business rule from the company, and what is the entities and so on. Okay, you need to define, describe from the company. Okay, so this is the example. Okay, the rest is example. Okay, the component. This is one representation of the business rule. Actually, okay, the statement is the school operates, okay, one to many departments. Within one to many departments means that the school operates minimum they can have one department up to many department. Tapi bila dia dah transfer kepada table ni, dia dah jadi bentuk macam ni lah. Because this makes easier to draw the ER. Okay. The department has at least one to many student. It means that no department has 0 student. One department employs one to many professor. One department offers many courses. Because one course is not offered by many departments. That is compulsory. Only one department that can offer that course, specific one course. The course generates one to many class. The professor is dean of one and only one school. Tak boleh lah satu professor to become a dean for multiple school. This cannot be. Yeah, so that's why the situation is the connectivity is one to many. And one professor chairs only one and only department. The professor cannot chair many departments at one time. At one time. Okay. So I believe that this kind of table helps you after you are receiving the information from the company in sentence, okay, in a statement, then you can draw this table, okay, to define the information before you convert it into the ER, the modeling, the ER diagram. Okay, so it's very clear. Okay, from this, finally you can have this one. Okay, this situation, this ER. Yeah, this is UML, but when we can just simply convert it into the ER also. Okay, it will be the same unless they are form of syntax. Okay, database design challenge. Okay, the conflicting goals. Database designer must make design compromise. Conflicting goals, design standard, processing speed, and information requirements. So it is very much important to meet the logical requirements and design convention. Okay, design is of little value unless it delivers all specified query and reporting requirements. Yeah. So from all of these, in database design, we also have the challenges. Sometimes we have a conflict, the goals between the designer and also the company. So we must make the compromise. Okay. Usually on the design standard, the processing speed. Okay. Kalau in the case of the processing speed is the way data is kept. For example, they put everything in one single table. They do not do the normalization. It is not an error. It can be done. Okay, you put everything in the you put every attributes in one single table or only one or two table without normalize it. Yes, it can be done and the processing will be faster, but they can confront with several problems like data redundancy. Okay, and the standard of the database itself is not very good. It's not efficient when it comes to the data distribution. So this kind of database is not good. Okay, not efficient. What I mean by putting every attributes in one single table is like this. Okay, this is example. Student table, student for example, student. Some student, you lah. Okay, to ease your task, you put many information here. Sedangkan okay, table student, the attributes for student is only like student ID, the name, what else? What is related to the student? The age, how about the course, the class, the parent name. What else? Kan? Semua you masuk sini. This is what I meant. You put every attribute without consider the actual entities. You put everything in one table. Actually, the cost is not belong here. The cost is not belong here. It should be replaced by cost ID only, but not the cost name. It should be in a table cost. Parent, it should not be here. They should have the table or entity parent with the specific attribute. So this is what I mean by if you put every attribute, either it is related or not related in a single table, the situation becomes not normal. Not normal. Okay, it can be happen. You can use the data. You can make the operation. You can select this from the. You can do the SQL and so on. Sure, you can. But we face the data of redundancy. The database is not very good. So it doesn't follow the standard that entity must contain their own attributes. They are related attributes. They are belongings attributes. Kan? Dah lari daripada dia punya tujuan asalnya lah. Okay. Dia tak salah, boleh digunakan, tapi tidak bagus lah. Okay. So this is we came to the summary. Okay. Again, the ER uses ERD, okay, to represent the conceptual database. Okay, conceptual means the concept tau. So when we implement it in real, maybe some changes in logical database is happening. Okay, ERMs, okay, contain entities, relationship and attributes. Also connectivity and cardinality. Connectivity ni one to many, many to one. The 4 classification tadi kan, and the cardinality is the degrees. The how is the minimum and what is the minimum and maximum number if you have. Okay, and those based on the business rule. Okay, see, many to many relationship is valid at conceptual, but it must be mapped again to be a one to many relationship finally when we go to the logical database. Then ERD may be based on many different ERMs. Okay, yang ni saya belum ajar. So this is not learned yet. So I will carry forward this for the next week. Okay, next lesson. Okay, so any question? Yeah, this is example, and I also have exercise at the end of the slide, so you can try. Okay, the exercise of this. So we will discuss the exercise on next week. Okay.